Hi class, welcome to Lesson 17, part of Unit 2, Matter and Energy. Today, we are going to predict the behavior of gases under changing temperature, pressure, and volume. We'll do this by utilizing the combined gas law, making sure we can identify the conditions of STP for all gases. To use the combined gas law, we must recognize that models of gas are dependent on volume, which is measured in either liters or milliliters, temperature, which must always be in Kelvin, the number of moles of a gas, which will be held constant in all of these examples. So we're going to be discussing the behavior of gases in sealed containers where no gas can enter or no gas can exit, like your bicycle tire, a basketball, or a syringe filled with gas. We'll also be looking at the pressure of a gas. Pressure is measured in either atmospheres or kilopascals. We are going to be applying the combined gas law, which is found here on your Regents chemistry reference table. There are 3 steps that we'll need to use in order to solve problems using the combined gas law. The first step is we're going to make a variable table, just like we did in heat calculations. Then we're going to make sure we convert any temperatures that are given in Celsius to Kelvin. You can find this equation also on reference table T. Lastly, if any of the environmental conditions of pressure, temperature, or volume are constant, we will eliminate them. Together, we will solve 3 questions using the combined gas law. Then you will solve some by yourself. As you read the question, identify the variable. So we begin with 0.180 liters. This is a volume. Because it is the first volume given, we'll call it volume 1. And we're given a pressure. Because this is the first pressure given, we'll call it pressure 1. And finally, we're given a temperature. Once again, the first temperature is temperature 1. We can see that we're looking for a new temperature, and we are given a second volume that we will call volume 2, and a second pressure that we'll call pressure 2. You can see I've organized my variables in a variable table below. Since we're using the combined gas law, we can look at our variable table and guide us in our substitution. Once we have this set up, we can always solve by cross multiplication. Using algebra, I find that T2 is 604, but this is given in Kelvin. I need to convert back to Celsius. Recall that Kelvin equals Celsius plus 273. Solving this equation, I see that the new temperature is 331 Celsius. Let's try this problem. Here, we are given a volume of 4 liters. That is volume 1. We are also given the conditions of STP. The conditions of STP can be found on reference table A. Since our pressure is given in atmospheres, we're going to use the STP pressure in atmospheres. when we always use Kelvin when solving gas law problems, so that we're going to take the Kelvin temperature for STP. We were given a second temperature, but it is in Celsius, so we're going to have to convert to Kelvin. Here we're looking for a volume, so volume is undefined. And we see that the pressure was 2. Now we have all the information listed in our variable table so that we can solve this problem. Once we get our variables substituted into our equation, we can use cross multiplication to solve this problem. I find that my new volume is 2.2 and will match the units, so 2.2 liters. Let's try this sample together. As we read, we are given 3 liters. That is volume 1. We are given gaseous sulfur dioxide, and the pressure is 1 atmosphere. That is pressure 1. We see that we are changing the pressure to 1.5 atmospheres at a constant temperature. Since temperature is constant, we're going to remove it from the equation. So here we're simply looking for the second volume. Since temperature is constant, it is removed from the equation. Now our formula simply looks like this. To solve this, we simply use algebra to determine that our new volume is 4.5 liters. Here is a Regents practice question for you to try on your own. Did you get choice 4 when you round to the correct number of significant digits?